Hello everyone. In this lecture we are going to solve this particular pipelining problem. Okay, so this question seems to be lengthy, but believe me, this question is very easy. Okay, so let's see. The processor uses a 4-stage pipeline. Okay, that is fetch, decode, execute, and write back. Okay, it's exactly like the theory which we had seen previously, and it contains 6 instructions. Okay, you can see there are 6 instructions. Each instruction spends a different number of clock cycles in each pipeline stage as listed below. Okay, so let's see this data, what this data means. Okay, so this data means instruction 1 at fetch cycle. Okay, that means instruction 1 at while fetching it takes 1 clock cycle. Instruction 1 while decoding it takes 2 clock cycle. Instruction 1 while executing it takes 1 clock cycle. Instruction 1 while at write back stage it takes 1 clock cycle. That is the meaning of it, right? Similarly, instruction 2 at fetch stage it takes 2 clock cycle, while decoding it takes 1 clock cycle, while executing it takes 3 clock cycle, and write back it takes 1 clock cycle. So similarly all this data is represented, right? I3 also same for fetching 1, for decoding 2, for executing 2, for write back 2. Okay, hope you understood what I mean, right? Now if you want to represent this data, you can even represent in a simple way. You can take represent in a tabular form. Okay, so what you have to do is just draw the table. Okay, or in the row you mention instruction like this. And in the column you mention fetch. In the column you mention stages. Okay, like this you fill the table. Okay, you just design the table, and after that go to the instruction 1 at fetch it's taking 1 clock cycle. Instruction 1 at fetch it's taking 1 clock cycle. Fill it. Instruction 1 at decode it takes 2 clock cycle. Instruction 1 at decode it takes 2 clock cycle. Instruction 1 at execute take 1 clock cycle. Instruction 1 at write back take 1 clock cycle. Like this you fill the table. Okay, instruction 2 at fetch it take 2 clock cycle. Instruction 1 at decode is take 1 clock cycle. Instruction 1 at execute is take 3 clock cycle. Instruction 2 at write back it take 1 clock cycle. Right, so I think you got it, right, how to fill this table. Okay, even if this table is not there, still you can solve like this. Okay, so in question might be, okay, in the question it may be like either this or in this way, any format would be there. Okay, so you should understand, that's why I'm solving this. Okay, anyway, I3 for fetch 1 2 2 2, I4 1 3 1 2, then 2 1 2 1, then 1 2 2 1. So like this you fill the table. Fine. Okay, now before solving this question you have to assume certain thing. Okay, so that is what is written here. Each stage can handle only one instruction at a time. Okay, so at one stage only one instruction can be processed, right? Second is one instruction cannot move to the next stage until the required cycle in the current stage are completed. Yeah, definitely. When some at one stage if certain instruction is processed, and after certain clock signal only that particular stage can move, that particular instruction can move to next phase. Okay, this thing we had seen in the theory also. And second is no pipeline overhead. Okay, what does it mean is, see, overhead. So we had already seen see, overhead comes whenever there is an extra delays. Okay, so we had already seen some delays that when we are considering a pipelining, we are dividing into functional units, right? And each functional unit is combination of it's a combination of combinationary circuit which will take some delay. Apart from that there is a register also which also takes some delay, right? So apart from that thing there are few more delays are there which we are not considering while solving the pipeline. That is synchronization delay is there. When a data next delay is switching delay is there. Switching delay means when one data is moving from one stage to another stage, at that time also some delays are there. Okay, or from decode to execution when data is moving, at that time also some delays are there, that also we are not considering. So all many data control signal setups, for control signal setups there are some delays are there. So all these particular delays we are ignoring while solving this particular question. Those are extra delays, that's why it is called overhead. Okay, so those delays are ignored. If at all that delays are mentioned is there, then it will be mentioned in the question itself. Okay, so don't worry about that part, right? So in the question itself it is mentioned. So if it is not mentioned, okay, in the question if it is not mentioned, then you solve in that way only, that there is no overhead, right? Fine. Okay, now we have to solve the question, that is construct a pipeline execution timeline. Okay, that we are going to see. Then determine the total number of clock cycle required to complete all the instruction. Okay, so we will solve this part. Okay, let's see how to calculate the number of clock cycles. So for that we will take help of one phase time diagram. We are already seen phase time diagram, right, in one of the topics. Okay, I think here, right, this is our phase time diagram. So in this what we are done is that we can see at column part we had put the clock cycles, okay, and at row we had put the phases, that is stages, right? Now what we will do reverse. What we will do is we will put these instructions now, okay, instruction at the row part, and we will pull these particular stages inside the cell. Okay, why I am doing it? So that you can solve that particular question easily. When we do this reverse engineering, when we do this reverse thing, then the question, solving that question would be particularly easy. That's why I will show you that with example you will understand, right? So we will try to that we will try this phase time diagram. We will design this phase time diagram again, and we will see how we can solve that. So here you can see at row I had put a instruction, right, and at the column I will put the same that clock cycle, right? Now at the beginning we can't know how many number of clock cycles are there, right? So we will just assume it randomly that this much clock cycles are there, then we try to solve it. So just put some random numbers, right, like 10 to 12 clock signals, and then try to solve it, right? And while solving, if we find that there are more clock signals are required, then we keep on adding those columns, right? This is how we will try to solve it. So at the beginning you try to put some random clock signals, right? 1, like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, fine. If it is required more, we will put more clock signals. Okay, clock cycles, fine. Then put this column also, then try to make this column also, fine. Okay, I will fill this, then I will again explain, right? Okay, so this is how you design the pipeline execution timeline diagram. So you try to make this table, fine, and after that you have to solve the problem. So go to this particular data. Okay, what it is written, right, at instruction 1, okay, fetch cycle means fetch stage is taking 1 cycle, right? So how can you fill this data here? At instruction 1 take 1 clock cycle for fetching. So you write, okay, what you have to do is just write fetch 1 time. Right, now you can see instruction 1 at decode take 2 clock cycle. So here instruction 1 take 2 clock cycle, right? Decode take 2 clock cycles. So you write decode 2 times, right? Now instruction 1 at fetch take 1 cycle, at execute take 1 clock cycle. So you go to instruction 1 and execute 1 time, right? At instruction 1 at write back take 1 clock cycle. So write back take 1 clock cycle, so write it 1 time, right? In this way you have to fill this timeline, right? Now again go to the next data, that is instruction 2, right? So you can clearly see instruction 2 at fetch take 2 clock cycle. Now there would be a problem. You might be thinking, right, from fetch, where should I start a fetch? So don't start fetch from here, this is wrong. Okay, what I mean is, for that you have to understand these nodes. These nodes I had already written, that at same clock cycle there should not be two stages or phases, right? At same clock cycle you can't use two stages. So when fetching is being used, okay, so what I mean is you can't start a fetch here, okay, because fetch is being used by I1, okay, fetch is being used by I1 at clock 1, right? So you have to start fetch here. So at second clock you will start fetching, right? Now how many clock signal, how many cycle it is taking for fetching? 2 cycles, right? I2 is taking 2 cycles, so you have to write 2 times, right? Now I2 is taking 1 clock cycle for decode, so you write decode here 1 time, right? Now I2 is taking 3 clock cycle for execution, so you write 3 times, it is execution 3 times, so write 3 times execution. So at 5, 6, 7 clock cycle execution is happening, that is a minimum, right? Now I2 is taking 1 clock cycle at write back, right? So you write write back at 8th clock cycle, okay, this is how you have to fill it. Now go to the next data, that is I3. Now let's see. Now I3 will start its fetching, right, and it will take 1 clock cycle. So shall I start from here? No, you can't start from here, because at first clock I1 is utilizing the fetch cycle, this fetch phase. Can I start from here? No, you can't start from here, because I2 is utilizing the fetch stage, okay. Here also you can't start fetch, because I2 is still utilizing that fetch stage, right? So you have to start your fetch from 4th clock cycle, okay. So your fetch phase began from 4th clock cycle, right? Now how many cycle it required for fetching for I3? Okay, only 1, right? So 1 time you write it. Now coming to decode, it is taking 2 cycles, right? So decode 2 times, and for execution it is taking 2 cycles, so it will take 2 cycles. Can I start execution from here? No, because execution is utilized by instruction 2 at 7th clock cycle, right? So you can't write execution here, so you have to start execution from 8th clock cycle itself, right? So you can clearly see this particular phase, this particular cell is empty now, right? Now I3 for write back it is taking 2, okay, for execution also it is taking 2, right? So I will write 2, right? For write back it is taking 2 clock cycle, right? So at 10th and 11th it is taking write back. It is doing at 10th clock cycle and 11th clock cycle, I3 is performing write back, that is the meaning of it. Fine. Okay, now let's try to execute I4 instruction, okay. So for I4 1 cycle is required for fetching, right? So can I start from here? No. Can I start from here? No, because I2 is utilizing it. Still I2 is utilizing fetch phase. I3 is utilizing fetch phase now. So you have to start your fetching from 5th clock cycle. So I4 will start its fetching from 5th clock cycle. Or how many cycle it is taking? Only 1 cycle. So it's fine now. Now I4 decode. Can I start decode from this phase? No, I3 is utilizing that decode phase. So you have to start from this phase. And how many clock cycle it is taking? 3 clock cycles. So write is 3 times. So till from 7 to 8, 7, 8, 9, all this clock cycle is performing decoding for I4, right? So I4 is performing decoding at 7, 8, 9 clock cycle. Now for execution it is taking 1 clock cycle, right? So you can start at 10th clock execution. And for write back, okay, can I start write back from here 11th clock cycle? No, because I3 is utilizing write back. So you have to start from here. and right back it is taking 2 clock cycle, right? Yeah, so you need one more column, right? This is how, while solving, you will understand that you have to add one more column, that is for 13, right? Okay, so you just add, I think you will require few more. Okay, so we will add few more, then we will try to solve, right? Okay, so I added few more clock cycle because we know that we required more clock cycles, right? So while solving, I told you now at the beginning only, you just randomly put some clock cycle, then try to solve it. 10 to 12 you start it. Okay, if it is not required, you don't go for it. Okay, when it is while solving, you come to know that you need more clock cycle, then you add the columns there, right? So we understood that I4, right? We were solving I4 and it is taking 2 clock cycle, right? Fine, it is done. Now coming to I5. Okay, so I hope you understood, right? Now I am going little bit fast. So at I5, can I start fetch here? No, I can start fetch at 6th clock cycle, right? It is fine, right, for I5. And okay, it is taking 2 clock cycles, so 2 times fetch. Then decode. For decode, it is taking 1 clock cycle. So can I start from here? No. Can I start from here? No. Here? Yes, I can start decode from here, right? So at 10th clock cycle, I5 will decode the phase, and it is taking only 1 clock cycle. And execution. Can I start execution from here? No other. See, you have to check parallelly at the above. Is there any other instruction utilizing execution phase? No. You can clearly see there is no execution phase at the above. So you have to go at every instruction. You have to look at every instruction at the above and see whether any one of this instruction is utilizing that particular phase. If any one of them is utilizing, you can't execute. Okay, you can't perform execution at 11th clock cycle for I5, right? But in this case, no one is utilizing that particular phase. That's why I am executing at 11th clock cycle for I5. Now, okay, coming back to the question. Now, execution is taking how much? 2 clock cycle, right? So we are executing 2. Write back takes, I think, we can't execute because I4 is utilizing that phase. So write back comes at 14 clock cycle. Okay, now I6 fetching will start from 8th clock cycle, right? And fine. Now decoding. Can I start decoding here at this phase? No. I4 is utilizing decoding, right? Can I start from here? No. I5 is utilizing decoding. So I have no option. At 11th clock cycle only I will start decoding for I6, and it takes 2 clock cycle. Now what about the execution? Can I start from here? Yeah, you can start, and it takes 2 clock cycle. What about write back? It takes 1 clock cycle, right? So we had filled this timeline, right? All this particular is finished, and my question was, what was the question? How many number of clock cycle are required to complete all the instructions? So how many number of clock cycle is required? 15 clock cycle. So that is the answer. So the answer is 15 clock cycle. So for this, the answer is 15 clock cycles are required. This clock cycle we are not used it. Okay, you just discard it. So that is the answer, right? Okay, now the next question is compute the pipeline speed up, right? You have to compute the speed up compared to the non-pipeline. So we already knew this particular part is easy, right? So for C, we already knew what is the formula for speed up. Speed up is time taken without pipelining and time taken with pipelining. Now how to calculate time taken without pipelining? Now in this particular question, see, we know whenever we want to calculate a time taken without a pipelining, what we are doing is from every phase we remove the delays, okay, and directly add the delays of all the phases, right? So you can clearly see in the question itself, delays are mentioned, right? This clock cycle is nothing but the delays. For instruction 1 at fetch cycle, it is taking how much? 1 delay. At decoding, it's taking 2 clock cycle delay. Execution, 1 clock cycle delay. Write back, 1 clock cycle. So these all are nothing but a delay only, right? So what you have to do is you just add up them. 1 plus 2 plus 1 plus 1. What is the answer? 5. Right, like this. For instruction 2, what would be the delay? Right, 2 plus 1 plus 3 plus 1. What is the answer? 7. And for instruction 3, what is the delay? 1 plus 2 plus 2 plus 2. 2 3s are 6 plus 1 7. Right, for here 1 plus 3 plus 1 plus 2. How much would be the answer? This also 2 3 4 7. And this 2 plus 1 plus 2 plus 1. How much? 2 2s are 4, right? 6. 5 6. And this also 1 plus 2 plus 2 plus 1. So this is the delay for instruction 6, I6. So 2 2s are 4 plus 5 6. Right. So we got all the delay. Now this is a delay for all the instructions, right? Now this is for one particular see, these delays are for individual instructions, right? You have to sum it up all. You just add everyone. You just add up every delays. Then what would be the answer? Then you will get, that means 5 plus 7 plus 7 plus all this delay, you just add up and you will get 38, right? 5 7 yes 6 6 12, right? 38, right? So you will get 38 cycles, right? So this is the delay for without pipelining. So 38. And with pipelining, what is the delay? We had already calculated. With pipelining we got 15 clock cycle. So you just write it 15, right? So what would be the answer? It is equivalent to 2.53. Okay, you can do the math. This is the answer, right? So this is how you solve this kind of question. Hope this question might be lengthy, but it is one of the easiest one. Okay, so try to solve it 2-3 times, you will get it. Okay, and don't forget about this particular timeline. Okay, we had already seen the phase time diagram. Okay, I just reversed it, that this clock cycle, I just in back then in phase time diagram I had mentioned a fetch stages here at the rows, okay, and all the instruction inside the cell. Now I just reversed it. I had mentioned phases outside, okay, sorry, instruction outside and phases inside the cell, and so that solving this kind of question would be easy. So whenever I am talking about efficiency and performance, then you go for that phase time diagram which we had seen already. Okay, I will show you this part. Okay, then you go to this particular, whenever I am talking about efficiency and performance, then use this particular phase time diagram. Okay, whenever I am talking about clock cycle, then you use this particular timeline diagram. Okay, so that is the difference. Okay, hope you understood. Fine.